Hello everyone. Today we will be bringing you through our investigation on the case of the disappearing structures. The key question in our investigation will be whether the rate of corrosion is higher at the Taj Mahal or the Colosseum.
We will be using three variables to come up with smaller scaled experiments to come up with our final conclusion. These variables are temperature, acid concentration, and surface area.
We will be using eggshells and vinegar to represent the buildings and the acid rain respectively.
Using these calculations, we have calculated that for every 3 grams of eggshells, 72 cubic centimeters of vinegar is needed for the reaction to happen fully. Firstly, we will be investigating the effect of temperature on the structure's rate of corrosion. From our research, we found out that the average annual temperature of Uttar Pradesh, India is 26.0 degrees Celsius, while that of Rome, Italy is 20.0 degrees Celsius. In planning our experiment, we have made many assumptions, and the main assumptions are that the egg and vinegar are 100% pure and that the concentration of acid rain in both countries and the surface area of both structures are equivalent. For this experiment, we will be changing the temperature of the setup to measure the difference in the setup's mass loss. This will be done while keeping almost all the other variables constant due to our assumptions made. These are the steps that we came up with for the experiment. Step 1. Measure 2 sets of 72 cm³ of vinegar and 3 grams of eggshells. Step 2. Cool the 2 sets of vinegar with ice until they reach a temperature of 20.0 degrees and 26.0 degrees respectively. Step 3. Place the beakers on a weighing machine each and add in the 3 grams of eggshells into both beakers. Step 4. Record the mass of the beaker every 10 seconds for 1 minute. These are our experiment results, and the rate of reaction for the setup cooled to 26.0 degrees Celsius is 0.009 gram per minute, while that of the setup cooled to 20.0 degrees Celsius is 0.005 gram per minute. From this, we can conclude that a higher temperature results in a faster rate of reaction between calcium carbonate and ethanoic acid. Collision theory states that in order for a reaction to happen, two conditions must be met. First, the particle must collide, and the second, the particles must collide with sufficient energy, which is also known as activation energy. How does temperature affect these two conditions? Well, higher temperature increases kinetic energy in particles, hence particles will move faster, increasing chances of collisions, hence fulfilling the first condition in the collision theory. Furthermore, with the increased kinetic energy, the particles would collide with more energy, increasing the probability that the molecules will be moving with the necessary activation energy to break the chemical bonds between the particles, hence initiating a reaction. The following animation will show how the chemical reaction happens at the molecular level. This will be the ionic equation that is used to come up with the animation. This two diagram shows the acetate ions, hydrogen ions, and the calcium carbonate solid. The diagram on the left is at 20 degrees Celsius, while the diagram on the right is at 26 degrees Celsius. As you can see, the particles on the left move relatively slower compared to the particles on the right. This is due to more kinetic energy in the particles as the temperature is higher. With more kinetic energy, the chance of collisions between the particles will be higher, hence the frequency of effective collisions will increase, causing the rate of reaction to increase as well. This can be seen from the H+ ions reaching the oxygen ions faster at the right side, where there is higher temperature, as compared to the left side of lower temperature, forming H2 molecules and carbon dioxide in the process. As seen from our ionic equation, the acetate ions are spectator ions which have been removed from the ionic equation. Hence, there is no reaction between the acetate ions and the calcium ions. Since carbon dioxide is a gas, it quickly escapes into the air surrounding the reaction mixture. Hence, there is a decrease in mass of the reaction mixture. As mentioned before, since the particles on the right have more kinetic energy due to higher temperature, causing increase in frequency of effective collisions, the rate of reaction will be faster, hence rate of production of carbon dioxide will be increased as well.
Next, we will be investigating the effect of concentration of acid rain on the structure's rate of corrosion. Based on our research data, we found the annual sulfur dioxide and nitrogen oxides emissions of both India and Italy, as well as their annual rainfall volumes from research papers published online. We then use this information to determine the concentrations of the two countries' acid rain. Following that, we use this data to find the ratio between the two countries' acid rain concentrations and then calculated how much water we should add to 1 set of vinegar to replicate the acid rain. The assumptions in this experiment are similar to the previous, just that we assume the temperature instead of concentration of acid rain to be equivalent in both regions. We also assume that no pollutants are blown away to other countries by wind and that the amount of pollutants and rainfall is spread equally across both countries. For our experiment, we will be changing the concentration of the vinegar to measure the difference in the setup's mass loss. This will be done while keeping almost all other variables constant due to our assumptions made. Our experimental procedure is as follows. Step 1. Measure 2 sets of 72 cubic centimeters of vinegar and 3 grams of eggshells. Step 2. Add 50.4 cubic centimeters of deionized water into one set of vinegar and mix it with a glass rod, and then pour out 72 cubic centimeters of the resultant mixture into another beaker. Step 3. Place both beakers onto different weighing machines and add in 3 grams of eggshells each into both beakers. Step 4. Record the mass of the beaker every 10 seconds for 1 minute. From our experimental results, the rate of reaction for the beaker with a higher concentration is 0.015 grams per minute, while the rate of reaction for the beaker with a lower concentration is 0.013 grams per minute. Therefore, we can conclude that a higher concentration of acid rain results in a faster rate of reaction between calcium carbonate and acetic acid.
So, why does the increase in concentration of acetic acid quicken the rate of reaction between calcium carbonate and acetic acid? Well, the ionic equation for the reaction is that calcium carbonate plus hydride ions will give you calcium ions, water, and carbon dioxide. In this setup, we have the exact amount of acetic acid needed to react with calcium carbonate. The dissociated hydride and acetate ions will move around freely throughout the mixture. Then, the hydride ions will collide with the carbonate ions to form water and carbon dioxide. Do note that the acetate ions will not react as it is a spectator ion. Eventually, all the hydride and carbonate ions will react, leaving behind water, carbon dioxide, and calcium ions from the reaction. When we make the concentration of acetic acid 1.5 times of its original concentration, the number of reactant particles, which are the hydride and carbonate ions per unit volume, increases. This will also lead to the increase in frequency between the collisions of the reactant particles, as you can see here. Therefore, the frequency of effective collisions will increase, and hence the rate of reaction between acetic acid and calcium carbonate increases as well. Apart from this, it is also important that the hydride ions collide into the carbonate ions with sufficient kinetic energy and appropriate geometry for the effective collision to occur, allowing them to react.
Lastly, we will be investigating the effect of different surface areas on the structure's rate of corrosion.
Through research, we have found the height, length, and width of the Taj Mahal and the Colosseum. By assuming each building to be a rectangle, we made calculations and concluded that the Taj Mahal had a larger surface area compared to the Colosseum. The assumptions for this experiment are similar to the previous ones, except only for the concentration of acid rain and temperature in both countries is assumed to be the same. For this experiment, we will be changing the surface area of eggshells to measure the difference in the setup's mass loss. This will be done while keeping almost all the other variable constants due to our assumptions made. In conducting this experiment, we followed through these steps. Step 1. Measure 3 sets of 72 cubic centimeters of vinegar and 3 grams of eggshells. Step 2. Leave one set of eggshells alone and break apart the other set of eggshells to smaller pieces, and lastly use the grinder to grind the last set of eggshells to powder. Step 3. Place the beakers onto different weighing machines and add in the eggshells. Step 4. Record the mass of the beaker every 10 seconds for 1 minute. Our experimental results is as follows, and we concluded that as the surface area increases, the rate of reaction between calcium carbonate and ethanoic acid will also increase.
This is a close-up look of the reaction when using medium-sized eggshells. As the calcium ions and acetate ions is not included in the ionic equation, calcium acetate is not a product and is thus removed from the animation. As you can see, not all of the particles form effective collision between carbonate and H+ ions, but it was only a few that did not manage to form effective collisions at first. If you decrease the surface area, which we did so by taking larger pieces of eggshells, you can see that there are fewer effective collisions as compared to the previous experiment. As calcium carbonate is a solid, and there will be some carbonate ions that are covered by the other ions, thus are unable to react with the H+ ions. As the surface area decreases, there will be less exposed area for the ions to react with each other. Thus, the the frequency of effective collisions will decrease and the rate of reaction decreases. However, if we increase the surface area, which we did so by grinding the eggshells to powder, you can see that it has the most number of effective collisions compared with the previous two experiments. This is because as the particle size decreases and the surface area increases, the frequency of effective collisions will increase. Thus, the rate of reaction will be faster. Therefore, I can conclude that the larger the surface area, the faster the rate of reaction.
To conclude, the rate of corrosion at the Taj Mahal is higher than that at the Colosseum, as the Taj Mahal has a hotter climate, more acidic rainfall, and larger surface area than the Colosseum, all of which increases the rate of reaction between the limestone in the structures and the pollutants found in the acid rain.